So welcome back to the tutorial series on theory of computer science. So let's start from where we had left in the previous video. In the previous video we had seen how to design a FSM to check whether a given decimal number was divisible by 3. So in this problem the concept remains the same. This problem is basically for practice purpose. I have added a similar kind of a problem here. It is to design a FSM to check whether any given decimal number is divisible by 4. In the previous case it was divisibility by 3. In this case we have shown how to divide a particular decimal number by 4 using FSM. The entire logic remains same. Theory is obviously same. Step 1 is common. Step 2 is logic. Over here the input set will be same only from 0 to 9. Output will be either yes or no. The number of states will obviously change. In the previous case we saw that there were 4 states, that is the initial state QS, the state with remainder 0, state with remainder 2 and state with remainder 1. But in this case we are having one extra state with remainder 3. So in totality we are having 5 states: QS, Q0, Q1, Q2 and Q3. Clear? So now let's see the implementation step. It is also similar. We have added one state over here which is Q3. Obviously the transitions will differ over here because the columns have also increased. Basically there are 4 columns now for remainder 0, remainder 1, remainder 2 and remainder 3. If you are new to this problem, if you are directly jumping to this problem, I would suggest you to kindly go back to my previous video, watch it properly and then come back here. Otherwise you will feel alienated at the very beginning of this course. So I would suggest you to kindly go back and then come back here. Okay, so we are having 4 columns over here. Column 0 to accept all the values which give a mod 0, that is remainder 0. Same way for remainder 1, remainder 2 and remainder 3. Similarly the table is exactly designed on the same pattern. You can see I have mentioned the final states, or I can say the accepting state over here as Q0. So wherever we are having Q0 we have mentioned Y over there. Why? Because as you know, we had 2 functions: state transition function and machine application function. If you are not recollecting it, let me show you how. The state transition function was S into I gave S, whereas machine application function was S into I gave O, which is nothing but state on an input gives a state, whereas MAF was state on an input gave an output. So here we can see that QS on input 0 gives Q0, so which satisfies this STF. Similarly QS on input 0 gives an output Y, so it also satisfies MAF. So similarly we can design the entire table. I can leave the transition diagram up to you because you have already seen how to construct a transition diagram in the previous example. So the last step is nothing but the example or the simulation. I have taken 2 different examples. For simplicity purpose I have shown it here to quickly verify with the table. QS on 7, you can see QS on input 7 goes to Q3, so the remaining input is 284. Now Q3 on input 2, Q3 on input 2 goes to Q0 over here with remaining input 84. Similarly Q0 on 8, Q0 on input 8 goes to Q0 only with the remaining input as 4. And finally Q0 on input 4 stays in Q0 itself and there is no more input left and the machine is already in the final state Q0. So hence we can say that we will accept the string. Similarly on the other hand, over here we have taken a different kind of an example and we can see that at the end the input is read but the machine has not reached the Q0 state, hence we will reject such a string. So that's it for this particular type of a problem. I had mentioned that I would be solving different problems based on different types. So that's it for this particular type. Let's meet you in the next set of video to try out different problems or different type of problems. Thanks for watching. Do subscribe to my channel to stay tuned for more such videos on theory of computer science. Thank you.